Welcome to White Space, DCD's weekly roundup of news in the data center industry. This week with our special guest, John Laban of DCD Professional. John, we too have both been at the Open Compute Summit last week, and it was a pretty exciting event, wasn't it?
Yes, very. Yeah, passionate engineers that are working together, and they're working together in an open community. And therefore, you're getting this massive pooling of resources that's just not available when you've got a single vendor trying to do a development in a closed shop environment.
Yeah, that's right. I mean, it's the kind of thing that observing the industry, we're always saying, open source development and, pooling the resources to share benefits is the way to go. And then when you see it in action, you realise it's all true. It's amazing.
Yeah, it's the open software community again, but now in hardware.
Right.
The explosion in apps that started as a result of the back of open software community work. And I'm sure it's going to happen with the hardware. What we're going to see as products coming out in just the next 2 years is going to be very exciting, but it really is going to disrupt the way we currently build data centers. One thing that did come out that was fascinating was this. There's been extensive research by Intel and lots of big players, and the head of Intel development came out with a very interesting fact, he believes, and that's the way they're modelling their whole organisational structure, is that by 2025, 80% of all systems will be deployed in large and hyperscale data centers. Now, try and get your head around that. This is, it's probably down at 20% now, and it's going to move towards 80%. Where's the future for the smaller enterprise data center? I believe that the data center you're going to use in the future will be one that you don't own. It will be a utility, and you'll just bring up instances in a virtual world somewhere in data centers in that cloud.
Networks was something exciting, wasn't it, there?
Yeah, networks was very exciting. This year, Facebook are going to implement 100 Gigabit Ethernet on single mode using 2 cores. It's, let's call it, the nickname is 100 Gigabit Lite. It drives 500 meters, and it is 10 times cheaper than your standard 2-core single mode 100 gigabit 10 kilometer systems.
Right.
Why do we need 10 kilometers? They've said, let's engineer it to a data center environment. 500 meters is the longest length, and it's reduced the cost by a factor of 10.
Wow. And how does that cost compare with what people are currently using for that?
It puts it down right into the kind of the field of parallel optics on multi-mode, but then there's the benefit that you use 1/4 of the quantities of fibre in your data center with parallel optics using 425 gigabit channels, using 4 times more fibre. An example, I did a calculation for a client of mine in Turkey, and that one client, sizable data center with hundreds of racks, but over the next 3 to 4 years, they will save millions of dollars just on those fibre transceivers, and all that reducing the quantity of fibre they need within the data centre.
Right, because fibre isn't just fibre, it's labour, and it's clogging your airflow and all those other things.
Yeah, but to be able to reduce, for the same amount of circuits, to reduce the fibre quantity by 75%, you get down to 1/4.
Yeah.
And there was quite a few very excited people about this. In fact, I think Rackspace showed a lovely image of the problems in some of their data centers with the multi-mode parallel optics, that their trays are just kind of blowing open at the top.
Right, yeah.
And they can reduce that by 75%.
That's brilliant. Yes, I can see that's going to be exciting. And the telcos were there. They've arrived at in Open Compute only recently, which for me was an interesting thing because whenever people had talked about Open Compute to me in the previous year or so, there have been a room for scepticism when people said this is only suitable for the big web scale players like Facebook and Google. Few other people can do it. It's not going to get into other markets, and yet here they were.
Big time. All the big players in the telco market on the mobile side were there, and the big players, Deutsche Telecom, the big boys from AT&T, Verizon were all there. And just to put it into perspective how quickly this is going to happen and why they're using OCP, there'll be tens of thousands of micro data centers deployed towards the radio mast, the GSM mast, in order to push the processing out to the edge.
Yes.
And that's going to happen. They're going to be operational by 2018.
Right, and they have to be small and cheap and operate independently.
Yes, with lots of automation.
Yes.
Because these are unmanned locations.
Are those different demands there going to push the specifications of OCP? Because, I mean, OCP hardware hasn't been renowned for being very, very highly reliable, whereas these are going to have to operate without any attention.
Well, if there are any problems, they're going to solve them. But just look at what Nokia Networks have done. They've released all their new hardware platforms based on OCP.
Yes, tremendously significant.
You know, and the OCP Telco group only started, I think, 2 months ago.
And there it is. Yeah, it is.
January, wasn't it?
It's this year. Yeah.
Yeah. So it's a very exciting time, and the driving kind of applications behind it is 5G and the Internet of Things, where you must push out the processing and storage towards the edge more. You just cannot get all that data from all these sensors and all this high bandwidth video traffic. You just can't get it back. So there'll be a tiering of data center structures. There'll be the bigger core data center structure, the kind of the intermediate, and then the micro. There'll be this tiered level, and depending on the way the application works and its demand on latency, you'll start to see applications moving.
Is there any connection between the telco group and the arrival of Google? I mean, the common thread I see there is 48 volts DC.
Yeah, there is a connection. Now, that was a big announcement. We had the top guy on the technology side from Google. Google are now members of the OCP as of this month.
It was kind of unexpected, and they slipped it in at the end of the keynotes. It's like those teaser bonuses that you get at the end of the film credits when you watch a movie. Yeah. But so there it was. They've joined, and the thing they're sharing is not their server design, not their racks or any, it is racks. Sorry.
Yeah, but 48 volts DC distribution in the racks, and for a long time, I believe that really is the optimal way to go. And at last, I think there'll be a rapid take-up of that. Yeah. Now, the connection with the telco is Telco have always used 48 volts for years and years and years, 48 volts DC. So that would kind of ideally suit the telco rollouts, because if they do need to put any of their telco-specific gear in, then a 48 volt rack is ideally suited to service that. But the transformation that will occur in the telcos is that the telcos will be moving away from network concept hardware towards compute hardware. Yes. And they've got a massive problem of they need to retrain all of their people. AT&T, if you remember, said that they're setting up relationships with all the universities in North America to retrain all of their technicians into ICT.
Yeah. We need to talk about batteries.
Yeah.
Because that's been something that the OCP has been throwing out radical ideas about, and we think they're taking off now.
Yeah, they are. Last year there was an announcement by Microsoft on they insert these lithium-ion batteries into their server chassis and their storage chassis, and because of this enormous explosion in production of lithium-ion, for example, there's a partnership between Panasonic and Tesla. They're currently building a production facility in the States. And when it's built, it will probably have somewhere near that one factory will have the production levels for the rest of the world's production put together.
Yeah.
It's going to kill off valve-regulated lead-acid batteries in data centres. And I do believe, because you're seeing it in the hyperscale, it's killed off centralized UPS systems. And that will just roll down. We saw lots. There was lithium ion everywhere.
Yeah. Yes, that's right. I mean, Microsoft almost doesn't care what anybody else does with it. I was talking to Kushagra, who told me about it last year. And these little batteries go into your servers. It's a distributed UPS effectively, so you no longer need your centralized UPS. And even in an urban data center, that's a quarter of your floor space that you can do something else with.
The problem I had with British Airways on my journey out, that was a centralised power failure.
Right.
Took the main data centre down
in
Heathrow, which took offline over the weekend.
Right.
Not this weekend, the weekend before. All of their systems. So I couldn't get on my aeroplane on the Monday because all those people that should have flown out on the weekend took my seat and I got bumped off. And when I was coming back yesterday, it went down again. Now, if you distribute the power, so if you start to see failures, you see just partial failures on the edge.
Yeah.
You don't see this total wipeout.
Yeah.
And it doesn't matter whether you've got two redundant kind of working systems. They still have a tendency to interact with each other, but the energy savings are enormous as well. The 25% in space. Yeah. I could go on for a long time just on this one, but that's very, very exciting. Yeah. It's everywhere now. All the OCP players have kind of moved towards that. They're all embedding in their racks lithium-ion cells. Yeah. So you put your power supplies in the racks. Yeah. Within it, you've got the power supply unit, and embedded in the power supply unit, you've got the lithium-ion cells. It's so simple. And then you just bring in two three-phase feeds into two power supplies. Yes. You've got it. There's other things. Why you couldn't do it before with valve-regulated, because valve-regulated batteries, they're very critical on the temperature range. It might be 19 to 22. If you keep raising the temperature, you're basically half the life of the cell. But those lithium-ion batteries, they're rated at just around about, you can work them at 50 degrees centigrade. Right. And with no detrimental performance, no life restriction.
I mean, yes, that's essential with people increasing the temperature of their servers. And it's there, brilliant.
I must mention the Big Sur.
The Big Sur, oh yes.
Now the Big Sur, Facebook are getting into artificial intelligence big time. All the facial recognition systems, lots of really clever stuff they're starting to move into. And they need some high performance computing. And they've brought out these Big Sur computers. They put 4 in a rack. It's a computer with 8 powerful GPUs. Oh, wow. And they put 4 in a rack, and they're rolling them out all across the world in all their data centers. Just watch that one. Just watch that. The stupidity of spending money in the future on your own HPC when you've got that offering in data centers in the future in the cloud where you can just take up instances of these really powerful machines.
That's right. I mean, that's Facebook using them for its own purposes. But clearly, if they can do it, someone like a Google or a Microsoft Azure can offer them equally well for anybody's use. Right, well, thank you for coming and talking.
It's been a pleasure.
Enjoyed the trip.